Question 13 on integration and areas under curves. So it says figure 2 shows a sketch of part of the curve C with equation y equals x natural log of x. The line L is normal to C at the point EE. The region shown shaded in figure 2 is bounded by the curve, the line L, and the x-axis. So that's just describing the diagram. Show that the exact area of R is AE squared plus B, where A and B are rational numbers to be found. So what I'm seeing here is two separate areas that we've got to find. So the first area is the area between the curve x log x and the axis. So this area that I'm highlighting blue here. Then there's the red area made by this triangle here, which is the normal to the curve. So let's say, start with the blue area. So we're going to need to integrate that curve between two limits. So we know that one of the limits is E, so this limit here is E. However, we don't know this limit here, so we need to find it. So let's start with x log x. So y equals x log x. And we find what this limit is here by letting y equal 0, which means that x log x equals 0. Now you may be fooled into thinking that x equals 0 is a solution, but it's not, because it won't sub into the curve. If we let x equal 0, log of 0 doesn't exist, so 0 certainly isn't a solution. So the solution that we're going to have to go for is where log x equals 0, which implies log x equals 0, and if we e both sides, that means that we get e to the log x, which is x, equals e to the 0, which is 1. So that limit there is 1. Right, so now we'll find the integral between e and 1 of x log x dx. And here we're going to have to use integration by parts. So u equals log x. So when integrating by parts, u takes priority as being log x if a log x is in there. That's not a hard and fast rule, but most of the time it works. So that means that du by dx equals 1 over x. dv by dx in that case must be x, which means that v equals a half x squared. And the formula for integration by parts is given in the formula booklet, so you can just consult that. Therefore, our integral, which I'm going to denote by I, is equal to uv, which is a half x squared log x, minus the integral of v du by dx, so a half x squared times 1 over x, which is a half x dx between e and 1, which is equal to a half x squared log x, take 1/4 x to the power of 4 between e and 1, and then subbing in the limits, we get 1/2 e squared log e minus 1/4. And I've written x to the 4 there. That should say 1/4 x squared. X squared between e and 1, and then subbing the limits in, we get 1/2 e squared log e, take away 1/4 e squared, then sub 1 in and subtract that, 1/2 1 squared log 1 minus 1/4 1 squared. So 1/2 e squared log e is just 1/2 e squared. Take 1/4 e squared, and natural log of 1 is 0. So then we're going to double minus 1/4, so plus 1/4 equals, so 1/2 e squared, take away 1/4 e squared is just 1/4 e squared plus 1/4. And that's the first part done. So we're going to have to come back to this. So let's put a box around it. So we found out the area of the blue curvy part. So now all that remains is to find the area of the red triangle. So now for the red triangle. So first of all, we want to find the normal to this curve, x log x. That's that line there. Find the normal of that curve when x equals e. So let's differentiate it. So we've got y equals x log x. And we're going to use the product rule for differentiation. So u equals x, which means that du by dx equals 1. V equals log x, which means that dv by dx equals 1 over x. So that means that dy by dx equals vu dash, which is log x times 1, plus uv dash, which is x over x. So the differential is equal to log x plus 1. Let x equal e, which means that dy by dx, the gradient of the curve at the normal, is log of e plus 1, which is equal to 1 plus 1, which is 2. Therefore, the gradient of the normal is the negative reciprocal of that. Right, so now let's find the equation of the normal. So we've got y minus y1, and remember the point was EE equals minus 1/2 x minus x1. Now there's no need to rearrange this into a nice format, because we remember that if we go back up here, all we want is the x-intercept, i.e. when y equals 0. So leaving it in that format now is fine. Let y equal 0, which means that minus e equals minus 1/2 x minus e. Let's times both sides by minus 2, which gives 2e equals x minus e, which means that x equals 3e. Therefore, the area, so we'll mark this on the diagram, we've got this is 3e, so the base is 2e. The height, we can see, is e. So the area equals a half base times height equals e squared. Therefore, the total area is this area here, e squared. Then add this area here, which was a quarter e squared plus a quarter. So plus 1/4 e squared plus a quarter equals 5/4 e squared plus 1/4. And that's the answer in the form required. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.